Hey everybody, it's Mr. Morel here, and we are going to solve some super easy basic equations. These are things like you saw in 7th grade. You definitely worked with things way more complicated than this in ninth grade. I mean in 8th grade, and here we are in ninth grade. We're just going to use them as a foundation to start giving you some more complicated things and get us ready for some pretty tough stuff later on. So here we go. Question 1 is asking what's the difference between an expression and an equation. Well, again, it's kind of annoying for me to write sentences on the iPad. Well, that was weird. On the iPad. And so I'm going to kind of explain the differences, and then I'd like you to put it into your own words. But if you have an expression, let's say that we just got a really basic expression like 2x plus 4. Well, there's an expression right there. An expression is like a sentence that uses numbers and variables and operations put together. Well, an equation will take an expression and set it equal to something. So we could say that that expression was equal to a number. We could say it was equal to 7. Or sometimes it will take one expression and set it equal to another expression. So maybe that expression equals 3x minus 1. So that's the difference between an expression and an equation. And in short, an expression looks like this. It does not have an equal sign, but an equation does have an equal sign. Okay? So go ahead and write that in your own words, and if you need to pause the video to do that, that would be a pretty good idea. Let's go on to question 2. Question 2 says, though it might not look like it, x plus 3 equals 5 is actually a question in math language. What is it asking? So I'm basically asking you to phrase this in words. Write out the set like a complete question in words instead of in math language. So usually if you see a variable in like this, x, that usually can translate to mean which number or what number. Okay? So that's what I would write out first. What number? And I would expect you to write the full word number, not just this hashtag sign. Okay? Obviously, addition means plus. And then 3 equals 5. 5. I hate writing on the iPad. Okay, so that's all that's asking, and that's all you have to write. What number plus 3 would equal 5? And, the reason why I think it's important for you to be able to look at that and translate that in your brain is, for a lot of people, this looks really intimidating, and maybe you don't even know what it is. But it's just a question. Math is just a different language, and so we have to translate it into normal language, and then it becomes super duper easy. Well, if you were to answer that question, what number plus 3 would equal 5? Well, the answer is really 2. And there are tricks that we could use to find that, and we're going to start using those tricks later on. But as long as you can understand that basic question, when you get stuck on the test or a quiz, try asking yourself the question, try translating it, and see if you can get the answer without doing anything too tricky. So let's go ahead and do that down here. Give me just 1 second. Okay, so if we look at question 3, and notice that I actually got my numbers right in this video. Woohoo! 2 different ways that you can approach questions on this specific worksheet. I'm going to actually approach it the more difficult way to set us up for future worksheets, okay? But the first thing you could do here is just ask yourself that question in your brain, translating it. You could say, what number plus 2 equals 9? And if you do that, you're going to be able to just know probably in your brain, well, 7 plus 2 equals 9. And again, I'm going to kind of take you through the mathematical way to solve this question just because it's going to start helping us on the future worksheets. Now, I have a pretty unique way of teaching this concept to people. Most people have never seen this way. I kind of made it up. It's not something that I've seen other teachers teach unless they've seen it from me. But I call it the box of doom method. And essentially what that is anytime you see a variable, just one copy of that variable in an equation, and that's what we're solving for, you want to make a box. Okay? And sometimes it's helpful to write on top of the box the letter that we're solving for. And so we're solving for A here, and inside of that box, you're just going to write out what you see happening to that letter, and you're going to start closest to the letter and work your way out. Now, on this entire worksheet, we're only going to be writing one thing, so this is going to sound kind of stupid to do it on this worksheet, but like I said, I'm trying to get you ready for the future. So in this example, A is being added by 2, and that's all that's happening on that side of the equal sign. So what we're going to do is we're going to do the opposite of adding 2. We're going to subtract 2 from both sides of the equation. So A minus 2 is just going to leave us with A, and 9 minus 2 equals 7. Okay? So I know that that sounds a little complicated, but I'm going to keep doing it for the future. Alright, let's go over to question 5. Again, I only see one copy of my letter that I'm solving for. I see one C, and it's being added by 2. So I'm going to subtract 2 from both sides, and C equals 0. And I just want to point out that we can also check our answers. You're telling me that 0 plus 2 equals 2, so I could take out this C and put a 0 in its place. Is it true that 0 plus 2 equals 2? Heck yeah, it is. We know that that does equal 2, so we're in pretty good shape there. Alright, let's go to question 7. Question 7, we have our letter E. There's only one copy of it, so I'm going to make my box. And the only thing happening to E, remember we talked about this a couple videos ago, if there's no sign between a number and a letter, we're assuming that it's being multiplied. So in this example, E is being multiplied by 2. The way to undo that is to do the opposite of multiplication, which is to divide by 2. So 2E divided by 2 equals 1E, and 20 divided by 2 equals 10. E equals 10. And that totally makes sense because 2 times 10 equals 20. Alright. Again, I know that box thing is kind of dumb. Why don't we kind of get away from it? It seems dumb right now. There's a really good reason why we're doing it. But why don't we get away from using it and just try to kind of start doing that in our brain? So here we have one letter, G. It's being divided by 4. No need to draw out the box right now because it's one step. We can think about that. If G is being divided by 4, I want to do the opposite of divide by 4 and multiply by 4. So G, because 4 times G over 4 is going to just equal 1G, equals 1 times 4, which equals 4. Once again, that totally makes sense because if I took out the G and replaced it with a 4, 4 divided by 4 does equal 1. Let's go over here to question 11. Now in this question, I is being divided by negative 12. So it's just the opposite operation. And what I mean by that is here we've got our box. I is being divided by negative 12. Okay? When we do the opposite, we're just going to change the operation. I'm going to multiply by negative 12 still. I'm not going to multiply by a positive 12. So I'm going to multiply both sides by negative 12. And the reason why that is because negative 12 times I over negative 12, well that would equal, oh sorry, I just got a text message, negative 12I over negative 12, and that would equal 1I. Okay, we're trying to get it so that our letter is all alone. Anyway, so we're going to have I equals negative 48. And once again, that makes sense because negative 48 divided by negative 12 is a positive 4. Alright, let's go to question 13 because I did throw a little trick in here. We've got this pesky minus sign just sitting in the middle of this fraction. It can be confusing. But something that I wanted to remind you of here is that negative k over 4 is the exact same thing as we could move the negative on top of the fraction like that. So we would have negative k divided by 4. Or what we could have done also is we could have moved the negative down below to say that that equals k over negative 4. You can always do that. It's kind of like how subtraction is the same as plus and negative, and you get to choose which one is easier for you to use and to understand. To me, for what we're doing right now, this looks like the easiest thing to approach. So let me go ahead and erase these. I'm going to go ahead and slide that negative down there so that when I make my box, I can see that k is being divided by negative 4. Which means I need to do the opposite of that. I need to multiply both sides by negative 4. And when I do that, these negative 4's are going to divide to equal 1. It's just going to leave us with 1k. And then 4 times negative 4 is negative 16. Okay? Alright, let's go ahead and jump to the back page here. I'm going to do questions 15 and 20 for you. Now, this can be a little bit tricky, and I just want to tell you there are a lot of different ways to do it, just like we were talking about on the last page. There are several different ways to do this. There's going to be one that is easiest for you. Let me start with one that I think will be the easiest for everybody, and then kind of tell you how the concept works with our other methods. If you ever see a fraction in front of a variable like this, I mean like we do see here, kind of like with the negative sign, only, well, I'll actually take that back. We can move this m on top of the fraction. Okay? Saying 1/3 times m is the exact same as saying 1m over 3. And I guess it doesn't really, well, it kind of does pertain to this. Remember, if you ever have a 1m, we could just write that as m. Okay? So what I'm saying is that 1/3 times m, the way that it was written in this question, is the exact same as m divided by 3. Those mean the same thing. And I'm guessing, if you're anything like me, it's easier to see that as being m over 3 equals 4. Because then, you see m is being divided by 3, and so we can multiply both sides by 3 to get rid of that 3 down there, and we would have that m equals 12. And you could double check that in your calculator. Try typing in 1/3 times 12, and you're going to see that it's equal to 4. Okay? So that's one way to solve this. I just wanted to show you that our crazy method that we were using before also does work with this kind of a question, and it's especially helpful if you have a calculator, because for some people this is kind of advanced math. But we have our letter here, we've got m, and in our box, remember there's no sign in between here, so m is, we talked about how it's either being divided by 3, but it's also being multiplied by 1/3, and that's what we can see happening. So we can actually divide both sides by 1/3. And that looks kind of funky, but remember, like if you have 2m, we would divide both sides by 2 to help cancel those out. Well, that same principle applies over here. If you have 1/3, well, we can divide that by 1/3, and those are going to cancel out. So we also want to divide 4 by 1/3. Now, when you go type that in your calculator, you're going to want to use parentheses. So you're going to do 4 divided by, we always put fractions in parentheses, 1, and usually, depending on the calculator you use, your fraction button is the same as your divide button. So if you're going to type this in a calculator, this right here is the best way to do that. We're going to take 4 and divide it by 1/3. And if you do that, you're also going to get the answer of 12. Okay? Now I'm going to teach you one more crazy way that we can solve this that's kind of advanced, but if you can wrap your head around this way, oh my gosh, you are going to be so happy in the future. I'm not even lying. Okay, so, okay, here's what I want you to do. I want you to understand this idea. We're trying to get m to be by itself. Well, we're trying to get this invisible 1 to hang out right in front of, we're trying to get the invisible 1 in front of the m. One way we could do that is by multiplying a fraction by its reciprocal. If you see a fraction and you want to multiply it by something to get 1, what you could do is you can flip the numbers. Okay? Let me write an example here. If I had 2/3 x, and I wanted to get rid of the 2/3 and just have a 1 in front of the x, well, I could multiply that by 3/2. And the reason why I could do that is, well, look at it. 3/2 times 2/3. We were going to multiply the tops and multiply the bottoms, okay? And that would give us 6/6. And 6/6 is the same as 1. Okay, so let me do that up here. If I kind of flip the numbers, if I multiply this side by 3/1, and that means I have to multiply this side by 3/1. Well, 3 times 1 over here is 3. 1 times 3 over here is 3. So 3/1 times 1/3 just equals 1. These kind of cancel each other out, and we're just left with 1m on that side. And then 4/1 times 3/1 is going to equal 12. So I just showed you 3 totally different ways to get 12, all using things that we've already talked about. It's just different versions of those things. Okay? So you may want to use that, especially over here in 17. Pick one of those methods that makes the most sense to you. I'll also remind you on this question, though I'm not going to solve it, if you type a division question, like you're going to end up typing 19 divided by 3 in your calculator, if you get a decimal, I do not want the decimal. That's not allowed. I need you to write your answer as a fraction. So have your calculator convert that decimal into a fraction. And I also think we're going to be talking about stuff like that, or we did talk about stuff like that in class, but I want to see if you can kind of remember what we're talking about. And just another hint, this is not, the answer to this question is not 3. If you write 3, you're going to get the wrong answer. Okay, let's go down here, and I want to show you, level 3 students, 2 different ways that you could solve question 20. Okay, so the first way, and this is what I would do because it's too weird for me to wrap my head around this. Like if I make my box of doom and say what's happening to L, I don't know how to describe what's happening to L. It's not being divided by 6 because 6 is being divided by L. So the box here is kind of not really working for me yet. At least I hit a stumbling block. The easiest thing for me to do, once again, is to go to translating the question. 6 divided by what number equals 3? Well, most of you, if you just read that in your brain like that, like in an English language, if you can just translate that, you already know that the answer is 2. 6 divided by 2 equals 3. So that's one way that you could do this. Just translate it in your brain and see if you can figure it out. Lots of times you can. Sometimes you can't. Another thing that we could do is we could multiply both sides of this fraction by L. If I want to get rid of this L in the denominator, I can multiply both sides by L. Now there's one way that I kind of teach students to do this in class. If there's a fraction that's bothering you, we can kind of circle the bottom of that fraction and draw arrows that go to the other terms in the fraction, meaning you don't draw arrows to anything on top of the fraction. We're going to leave that alone. So we're going to draw an arrow over this way. And kind of like the Santa hat idea, that arrow is kind of like a multiplication arrow. And then what's going to happen is that the bottom part is going, or the top of that fraction is going to drop, so it's just going to be left alone. And then we're going to have L times 3, which is 3L. And to me, that looks a lot easier than what we were doing before. Okay, and that kind of is the same thing as what I was saying. We can multiply this side by L and this side by L. These L's are going to cancel out, leaving us with the 6, and then we have 3L over here. Alright, now it would be a lot easier to use our box. We've got an L by itself, and it's being multiplied by 3, and so I can divide both sides by 3 like that. And then L equals 6 divided by 3, which is 2. Same answer that we got when we just translated that in our brains. Alright, and let's see. Okay, why don't I go ahead and kind of start helping you set this up. Your mom gave you $20, so you have $20 to go to the store and get some soda. She doesn't know how many bottles she needs. She just tells you to buy as many as you can afford. So you've got this $20 bill. You go to the store, and you need to figure out how many bottles you can afford. Well, here's my help. I think that you know, because you're smart enough, you're 9th grade, that you can get 10 bottles. It tells us to use X to represent how many bottles you're buying. So we know that the answer is X equals 10. The trick is to write an equation that will get us that answer. Okay? So that's your hint. You're going to write out some equation. You're going to have, I guess here's your other hint, you're going to have some number times X is going to equal some other number. And your job is to kind of read through that question and see what numbers can you put in here, and then to actually solve your equation. Make sure you're getting the right answer. Okay? But I've already given you a hint. The blue hint is one of them. The fact that you're going to have some number times X, so some number times the number of bottles you buy, will equal something else. And then when you solve it, you need to get the answer that X equals 10. And once again, you're kind of on your own for level 4, but I will give you one hint. It's going to be really hard to just put 7 in our equation. So in level 4, the difference is it's going to factor in tax. But my big hint for level 4, and hopefully you go investigate this more if you need to, you will need to convert that 7% into a what is it called? Oh, a decimal. So one huge hint is to remember that 7% is a decimal. Okay? Then you're going to have to do some other stuff with that 7%, but this is a level 4 question, so you're going to really have to think your way through it every step of the way, or especially when you solve your equation. Look at your answer and ask yourself if that answer makes sense. The reason why I'm giving you this question here is to help you make sense of your answer. Okay? It might help you to think about your claim. What are you trying to say with your answer? And then go back through your evidence. Follow your evidence and make sure it makes sense. Okay, sorry, I'm over my 20-minute limit. I usually try to keep these under 20 minutes, but this was kind of a big concept, and I did a lot of setup in this video to help us get ready for the next video. I will see you in the next video.